What is the sum of the measures of the interior angles of a polygon with 16 sides? That's crazy. Or whatever number you have. I don't want to try to draw something with 16 sides. That would be crazy. But here's what I want to do really quickly. I want to show you a pattern for a formula. Now, we already know that every triangle, holds 180 degrees, right? That we know. Now let me go to some strange four-sided shape. You know, if you have, so this is, if you put in that line right there, this holds 180, this holds 180. So 4 sides is 2 times 180, right? Wouldn't you agree? A four-sided object has got 2 triangles in it, so it's 2 times 180. I don't even care what the answer is. I just want you to see the pattern, so I'm just going to leave it like that. Okay, let's keep going. So next, I'm going to do 5-sided if I can do this. 1, 2, 3, 4. Oh, no, it didn't work. Let me try again. 1, 2, 3, 4, 5. There we go. 5-sided object. Okay, I'm going to fill in. So what are you going to do? I'm going to do the same thing. I'm going to pick some point, like that point, whatever, and draw in that line. In fact, let me just do it dotted. Draw in that line and draw in that one. How many triangles? This is 180, 180, 180. So 5 sides. This is a 5-sided object, isn't it? Right? Let me make sure that's clear. 5 sides. 1, 2, 3, 4. 5 sides. This one had 4. 5 sides is what? 3 times 180, right? It's 3 triangles inside. So 5 sides, 3 triangles inside. 4 sides, 2 triangles inside. Are you getting the pattern there? Is everybody seeing that? Let's do one more, and then we'll wrap this problem up. I'm gonna try 6-sided here. Okay, 6-sided. I'm purposely trying to not make it clean, which is easy for me because I don't draw too cleanly. Pick any point you want, whatever. I'll just pick this point. Whoops, doesn't matter where you start. Pick one point though and start making triangles. There's 1, 2, 3, 4. So 4. That made 4 triangles, didn't it? 180 here, 180 here, 180 here, 180 here. This is 6 sides, 4 times 180, right? It's got 6 sides. 1, 2, 3, 4, 5, 6 sides. And there's 4 triangles in there. 4 times 180. Do you see the relationship? Do you see the pattern? So if you have 4 sides, it's 2 180s, 5 sides, 3 180s, 6 sides, 4 180s. So here's my question. In sides, what's the pattern? N minus 2 times 180. Everybody see that formula? How I derived that by looking at the pattern? That's all math is the study of patterns. Do you see that? I came up with a general formula. If you have n sides, it's going to be 2 less than that times 180, right? If you have 4 sides, it's 2 times 180. 5 sides, it's 3 times 180. 6 sides, it's 4 times 180. See how it's always 2 lower? You got to take the number of sides and subtract 2 and then multiply by 180. So the number of sides, subtract 2, multiply by 180. Okay, so they're giving us, so that's the formula right here. Let me put a box around that. That's the formula. So I go, okay, n minus 2 times 180, and they're giving me up here, what, 16 sides? So I plug in 16. 16 take away 2 times 180. That's 14 times 180. So I don't even have to draw the thing. See the power of a pattern? 2,520 degrees. 2,520 degrees. So there's the formula. Here it is, n minus 2 times 180, that you want to use for the total degrees inside of a polygon. Now that is on your notes. I just showed you where it came from. But here's the formula right here on your exam number 1 notes. And they did the whole picture. I found this nice picture where they did the same thing we just did. And then there's the sum of the angles for an n-sided object. N minus 2 times 180. As I just showed, we came up with the same formula. So you just got to subtract 2. 16 minus 2 is 14. And then multiply by 180 to get the total degrees inside of a 16-sided object. There we go.